Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to discuss the week 1 hour 1 tutorial for both NFTF and also FTF. Before we start, I hope each one of you already watched the video that I've posted in Google Classroom. Basically, the video already covered for everything that you need to know for 1.1 reactions rates. Okay, let's get started. So the questions ask you to write the differential rate equations for the following reactions. Okay, let's recall what is meant by differential rate equations. Differential rate equations states that they show the relationship between the disappearance rate of reactants and also the formation rate of products. Before we can get these differential rate equations, you need to first know what is meant by rate of reactions. So let's recall some other things that we have already learned. Rate of reactions is basically the changes in terms of concentrations over time. So we're going to get the concentrations over dt. And then we need to look at whether they are reactants or product or reactant. If they are reactants, means they are being consumed, means negative. If they are products, means they are going to being formed, so positive. Okay, but then will they be the same as differential rate equations? No, differential rate equations means you need to relate everything in these chemical equations. For rate of reactions, it's only for individual species. But for differential rate equations, we're going to relate every single species in a chemical equations because they are all related to one another. Apart from different signs that we're going to apply for writing the equations, so for the left hand side, we know they are being consumed, so negative sign. For positive sign is the product parts. Okay, we need to look at the coefficients for each species. So if we look here, for the first questions, we know that I minus got only one coefficient, OCl minus also one. Same goes to the Cl minus as well as the OI minus. So each of these species got only one coefficient. Okay, so these coefficients, we're going to put it as the denominator. Denominator means the lower parts of the divisions. So how do we write these rate differential equations? We must first start with the rate. Okay, you need to write the rate. If you didn't write this, means they are all wrong. Then followed by equal sign. Now we know that this rate of reactions belongs to I minus, OCl minus, Cl minus, and also OI minus. Then we know that both I minus and also OCl minus are going to have negative signs, so we put the negative signs before everything. And then we know that the coefficient is 1, so we don't need to write anything there. So simply put the concentrations of I minus over dt. And then followed by, since we have OCl minus, so another negative d concentrations OCl minus over dt. And then for the product parts, followed by these equal signs, we write it as positive signs because it is being formed. So d Cl minus over dt. Lastly, we have OI minus, also coefficients of 1, so positive d concentrations of OI minus over dt. Okay, so it will look like this. Now let's proceed to the next question. So we have 3O2 in gaseous state to becomes 2O3 in gaseous states. You must first check whether they are balanced or not. So if we look here, on the left hand side, we have 6 oxygens. Same goes to the right hand side, we have 6 oxygens. So how do we write this? We need to first start with rate equal to, now we're going to have negative or positive sign for O2 gas. Yes, negative, while O3 going to have positive sign. So then we write it as negative. Now look at the coefficients that we have here. We have 3. Whenever we have different coefficients, then we must take it as the denominator. So we write as 1 over 3, followed by the dO2 over dt. And then we have species of O3. Now we have positive signs since they are being formed. And then followed by the coefficients of 2. So we put it as denominator, 1 over 2. Followed by changes in concentrations of O3 over dt. Next questions. Check if they are balanced or not. So everything on the left hand side gonna have negative sign. Everything on the right hand side gonna have positive sign. And then we have coefficients of 4, coefficients of 5, coefficients of 4, coefficients of 6. Don't forget to make them as denominator. So again, we start with rate is equal to negative 1 over 4 d NH3 over dt. Another reactant here, so negative. This time around we have 5, so 1 over 5 d O2 over dt, followed by positive because they are product, and then coefficients of 4 means 1 over 4. Changes in concentrations of nitrogen monoxide, over dt, and lastly equal to positive 1 over 6 changes in concentrations of H2O. Okay, so this is how it looks like. So this is the rate differential rate equations. Next, moving on to the face-to-face questions. So we need to consider these reactions where ammonia gas react with oxygen gas to give you nitrogen monoxide and also water in gaseous states. Okay, so another extra information given here is about the disappearance rate of oxygen. So disappearance rates of oxygen is 0.020 molar per second. If we look here, we have a unit of molar and per second. So it means that this disappearance rate of oxygen for individual species belongs to rate of reaction. Okay, it only states here for oxygen. It doesn't state any number in that. So this value belongs to only, since this O2 is the reactants, so they're gonna have negative signs. So this 0.020 only belongs to negative changes in concentrations of O2 over changes in time. We then take the number 5 as part of this disappearance rate because they are just coefficients. We can multiply with other species. So this number belongs to the disappearance rate of oxygen, 0.020 molar per second. Okay, now the questions ask you to determine the formations rate of water. So if we look here on your chemical equations, we have water on which side? Water is found on your right hand side, means they are being formed, rate of formation, so they must have positive sign. So the questions ask for formation rate of water, which is positive d concentrations of H2O over dt. Right, now you have informations regarding oxygens, but then you want to find the informations about water. How are you going to relate these two by only have one informations about oxygens? So you need to do the differential equations because they relate everything in the chemical equations together. So every time you get this type of questions, you must first take out the differential equations for the following reactions. So since we have done the differential equations in previous questions, we have exactly the same differential equations, then we can use it again here. Okay, so now we have the differential equations for these reactions. So now focus on the questions and also the informations given. You already have the informations regarding oxygens, okay? And then you want to find about water. So what we need to do is compare these two differential equations to get your answer. Okay. Now we need to compare these two. So we have negative 1 over 5 changes in concentrations of oxygens over dt, okay, equal to positive 1 over 6 changes in concentrations of H2O divided by time. Okay, we know already the value of negative dO2 over dt is 0.02. So we can simply substitute this value here by considering this negative and also this dO2 over dt. So substitute the value with 0.02, and then this number 5 can cross multiply with the 1 over 6. So we're going to get 5 over 6, leaving only positive d H2O over dt. Okay, so we're going to have 6 over 5 times with 0.020. Lastly, we'll get the final answer of 0.024 molar per second. Okay, like this. Alright. Okay, next we're gonna find the disappearance of NH3. So you are free to choose whether you want to compare NH3 with water or NH3 with oxygens. You are free to choose any of them since you already got the value. So let's say we stick to the informations regarding oxygens. So we need to compare oxygen with NH3. So simply write negative 1 over 5 changes of O2 over dt equal to, so NH3 we have a coefficients of 4, so they both have negative value. So negative 1 over 4 changes in ammonia gas over dt. So we want to find the changes in concentrations of NH3 together with the negative sign. Okay, dt, because it already states disappearance. Your final answer, as in the value, cannot have positive or negative value. Right. So we know that this dO2 over dt together with the negative signs belongs to the value of 0.02. So we simply cross multiply the coefficients. Then you're gonna get, okay, so you will have 4 over 5 times with 0.020. So lastly, your final answer would be 0.016 molar per second. So this is the disappearance rate of NH3. So every time you get the final answer, you need to do the conclusions where the rate of formations of water is equal to 0.024 molar per second, while rate of disappearance of NH3 is 0.016 molar per second. Okay. This is the overall answer for these questions. Let's proceed to the next questions, which is question number 2. So these questions ask you to consider the reactions of nitrogen gas react with hydrogen gas to give you ammonia gas. So suppose that at particular moment during the reactions, molecule of hydrogen is reacting at the rate of 0.074 molar per second. So they didn't give you any hint about this appearance of formations, but what we could see here is they are giving informations regarding hydrogens. So look for the hydrogen. So our hydrogen is on the left hand side. So left hand side means they are being consumed. They are about to disappear or deplete. So we're going to have negative sign for this rate. And then the questions ask you to calculate the rate of formations of ammonia. So we are interested to find informations regarding ammonia. Okay, but you need to first take out the informations given here. So this 0.074 molar per second belongs to the hydrogen. So our hydrogen is about to disappear. So we need to take out the negative dH2 over dt. So negative dH2 over dt gonna have the value of 0.074 molar per second. Alright. By knowing this value, then you want to relate it to the ammonia gas. So what we should do? Yes, we need to do the differential equations just like before. So we need to write the differential equations for these reactions where you have rate is equal to, so we start with N2. So since we got only coefficients of 1, so we don't need to put any number here. So negative d concentrations of N2 over dt, followed by another reactant here is hydrogens, but since we have coefficients of 3, so we're gonna have negative 1 over 3 dH2 over dt. Last one, we have our product of NH3. So product gonna have positive sign with coefficients of 2, so 1 over 2. Changes in concentrations of ammonia over dt. Okay, right. So focus only on the species that we want to find and also species that already have their own informations. So we have informations regarding H2. Then we want to find new informations regarding NH3. But please bear in mind, this value of 0.074 doesn't include the coefficients. Okay. So now, compare these two rate of reactions. So we write as next to one another. So we have negative 1/3 dH2 over dt compare with positive 1/2 d NH3 over dt. Okay, so we know already the negative and also dH2 belongs to value of 0.074. We want to keep only the positive. So formations of ammonia means positive d NH3 over dt. So everything else we need to put aside. So 3 cross multiply with the 2 cross multiply with 1, 1 cross multiply with 3, giving you 2 over 3. And then we know the value of H2 is 0.074. So simply multiply this value, then you will get the final answer of positive 0.049 molar per second. Okay, yep, you can simply leave it as it is. So don't forget to write the conclusions where rate formations of ammonia is 0.049 molar per second. It is not always molar per second, but then in these questions they already give you in molar per second, then we need to stick to it. Okay, for B, we have depletions of nitrogen. So apart from having terms of disappearance, formations, they sometimes use depletion. Depletions means decreases over time. Okay, so nitrogens, as you can see here, nitrogen is on your left hand side, so means they're gonna have negative sign. You can choose to use the same informations for H2, or maybe you want to try for 0.049, but I'd like to keep it as for H2. You can try it on your own, but for this example I'm going to use the same one for H2. So we compare the one for nitrogen. So we have negative concentrations of N2 over dt equal to negative 1/3 concentrations of H2. Okay. So since we want to find for N2, so we don't need to rearrange them, simply substitute the value here. So we know already this value belongs to 0.074. So simply substitute, and then you will get 1/3 0.074. Then your final answer would be 0.025 molar per second. And as for the conclusions, you need to write rate of depletions of N2 is 0.0, where's my 0? 25 molar per second. Okay, I guess that's all for the first hour of our tutorial. So please revise this because I'm going to give you homework on weekend. Alright, thank you everyone. Assalamualaikum.